Hi folks, welcome to chapter 16. Let's start making some chips here. This is actually a pretty exciting episode. We are going to use a Libre and Sprute cam and the Tormach compression tapping head to tap a hole. So let's hop over to a Libre. We're going to make a new part real quick. Go into 2D drawing, select the correct axis, make a hole, and we're going to make that hole 0.201. Why? Because I'm going to tap a quarter 20 thread, and that uses a number 7 twist drill, and that diameter is 0.201. I'm going to put a box around this just so I can extrude it. I'll extrude it to 0.375 to 3/8, and now, as you can see, I've got a box with a hole roughly at my XY 0. We will export that as an IGS file, and I've imported that exact file into Sprute Cam already. I already have my 4 cam operations created, but I'm going to go through them one by one. The first thing I did was, if you can see, you need the part to be at the top of the part to be at Z0. So you select your part, in model, select your part, choose the spatial transformations, locate 0, ignore these two for now, and just choose Z-axis max, and that'll move it there. Then we'll go into machining. The first thing I want to do is set up a spot drill. I have a 1/2-inch spot drill down here, number 50. My next video that hasn't come out yet is actually going to be covering the tool table, so stay tuned for that. Spot drill, I used GWizard to tell me that a spot drill, a 1/2-inch spot drill, running at about 0.1 inches deep, about 1508 inches a minute. So sure enough, 1500, 8 inches a minute, 0.1 safe level, 0.1 safe level, 0 is my top. Gonna take this down to 80 thou, and that's all I need to do for there. Simple drilling. The next, I'll do a 1/8 inch pilot drill. So I have a 1/8 inch pilot here as my number 5 drill, or 5 tool, excuse me. Once again, use GWizard, running that at 5,000 RPMs, 15 inches a minute. Same thing, safe level 0.1. Same thing here. I'm just going to take it all the way down to 0.4. Side note, instead of having to go down to 0.4 to compensate for the angle on the face of the drill, you could actually choose drill tip compensation. I just double clicked on the hole here. Oh, actually, and I apologize, I forgot to tell you how to select the geometry. You select the geometry when you create a new operation by choosing center, and you just select that, click add. Oops. Let's see here what I got my center. Oh, I'll have to show you that separately here. Not sure why it's. Let me try it on a new operation. Roughing hole machining. Here's the new one. Center. There we go. Click add. That's how I added that. I'm going to delete that operation though. I did that same process for all 4 of these. The next will be my number 7 twist drill. So I've got a number 7 drill, a tool table here. Ran the feeds and speeds 3800, 17.1, 0.10, -4. Actually, I realize I need to take that a little deeper. No, I'm going on through hole here. Definitely want to experiment on through holes. And actually, you know what? Forgot to show you. I want to run the 1/8 inch is a deep drilling cycle that will cause it to retract fully every 70 thousandths. On this one, I'm going to do a chip break, which it doesn't retract all the way, it just backs up a hair to break the chip. And then finally, the tapping. Okay, so for the tapping, same thing, same hole geometry. I'll start out. You notice I've got tap selected here. I've got a quarter 20 tap, number 51 in my tool library. Feeds and speeds. For this, what you do is, or for any US or non-metric style thread, is you do 1 divided by the pitch times RPM. So if you do 1 divided by 20, that's 0.05 times 300 is 15. So I'm going to run it at 300 RPMs, and this, I've noticed Sprute has been doing this. You need to make sure it's on 15. We'll come back to that and make sure. A little bit higher safe level here just to be cautious. Same thing, 0, -4. I'll let you know, I need to make that deeper. Try that. And then here's the critical part. On drilling type, you want to choose tapping. You're going to use I'm using the tension compression tapping head from Tormach here. So it will be a floating style. The peck depth, you cannot peck tap if you don't have rigid tapping, which Tormachs do not have. So I just set that at 10 inches, which means it'll never get to the point where it pecks. I'm not sure that's the correct way to think about it, but it seems to be what's working for now. The 0.3 dwell time I got from a Tormach blog post, which you can see here is post 963, which states what I'm telling you right now, which is to set the dwell time to 0.3, which gives it time to stop before it reverses itself, and that's it. So let's see what happened here. Go ahead and run all these. I get green checks for all of them, so we'll go ahead, simulate, turn my stock on, turn my part off. Let's see, hit play, spot drill, 1/8 inch drill, number 7 drill, and then it doesn't actually show the tap creating the threads, but there it is. Okay, now let's make some G-code. I'm in the machining tab, click on post processor. You want to be on the tapper one. I'm going to put this on my desktop, click run. Now it's going to prompt you for a tapping feed rate modifier of 10%. I'll talk about this in a second. And now we've got our G-code. You should read this, the 4 pictures on the blog post. He discusses what the feeding tap rate modifier does, and then most importantly is we need to compare our G-code we just created to the tapping code. So let's pull that up. Okay, I downloaded the picture from Tormach, which is right here, and then over here I've got the tapping code. So let's just walk through it line by line. Spindle of 300 RPMs going forward at M3, that's right. Puts itself over the hole, that's okay. Now again it repeats the spindle command, and then now we should be right here. Now we go down to Z06. Now I got a problem. My feed rate did this to me again. Need to figure out why Sprute's doing that, but that's why I do this, talking out loud, and hopefully everyone else can learn as well. Let's try this again. I'll be right back. Okay, I just re-updated the value in the tapping feed rate, and this time it's stuck. Can't tell you why it worked now and it didn't before, but that's why we checked. So what it's doing is it's going down to -6 at 13.5. Now we said 15 was our feed rate, but what it's actually doing is that feed rate modifier of 10% slower down and then 10% faster on the way out. So gets to the bottom of the hole, spindle goes into reverse, dwells for 0.3 seconds. This all ties out to over here, and then retracts at 110% to Z of 0.25. So let's take a look at this on the mill. Alright, got a piece of scrap aluminum in there. Set Mach 3 to tool number 1, which is my punch-off tool. Come down. Set my 0. I don't care about the XY, I'm just eyeballing it so it's in the middle of this part here. Now I'll hit cycle start. Mach 3 will raise it, asks me for my 1/2 inch spot drill. That's tool number 50. Got it right here in my hand. Go ahead and put that in there. Hit cycle start. Next is tool number 5. This is a 1/8 inch twist drill. Hit cycle start. This will be a pecking. Next is tool number 6, which is a number 7 twist drill. Now I put in the tapping head, and then this is a 1/4 20 spiral flute tap. You don't want to use a hand tap here. Adjust this. Now this will go a lot slower, 300 RPMs. Cycle start. Wrap it down to 25 thou over. Pauses. Backs itself out. That's it. Let's take a... Alright, haven't even taken it out of the vise yet. Just wanted to show. The threads look beautiful. Let's take a closer look. Okay, here it is. Grab a 1/4 20 socket head cap screw. And that's a very, very nice fit. Very nice fit. And actually, it looks like I may not have tapped all the way through. And part of that has to do with the fact that I am sort of guessing on the correct tap depth of 0.6. I need to figure out the correct way to have the tap protrude through the right amount. Yeah. Oh, no. Barely wants to start back there. So that's the only little faux pas, but that's okay. You need to be a lot more careful if you're doing this on a blind hole, but on a through hole right now I can afford to guess like that. But until, see, it starts to get tight there, if I back that off a little bit, you can still see that's a very, very good thread fit. So pretty cool. I think that's pretty slick. Frankly, a lot of the time you just saw milling was spent on the tool changes and the retracting to the Z height. If you obviously were tapping multiple holes, you could perform those operations in between switching. So I am very, very happy, and more things to come. Thanks, folks.